Alright, good day class. We shall look at the distance between 2 points. Distance between 2 points. So we say let P having x1, y1 and Q having x2, y2. Then the distance between P and Q is actually the line PQ, which is defined from Pythagoras theorem as square root of x2 minus x1 all squared plus y2 minus y1 all squared. So this is the formula of the distance between the 2 points P and Q. Geometrically, we can actually have this line with your x and y axis intersecting. So this is your y-axis, and this is also what your x-axis. At this point, we have negative x, and we have what? Negative y. So for instance, let's say this is the line. I want to find the distance between these points, x1 and y1, and this point having x2, what? y2. So what is actually this distance? But we can actually produce a line here and also produce a line here and the intercept at, let's just say, R. So by Pythagoras theory, we're going to have this equation. So the distance between 2 points P and Q is actually square root of x2 minus x1 all squared plus y2 minus y1 all square root. All what? Square root. For instance, if P is equal to a point x1 and y1 having 3, 4, and Q is also a point having x2, y2, let's just say 1 and 2, we can actually find the distance between these 2 points, P and Q, which is actually the line PQ, which is going to give us square root of x2 minus x1. And what is the x2? x2 is 1. So we're going to have 1 minus x1, which is 3, all squared plus we have y2, which is 2, minus 4. We have 2 minus 4 all squared. So at this point, this is going to give us square root of 1 minus 3 will give us negative 2 all squared. 2 minus 4, we have negative 2 all what squared. So at this point, after simplifying, this will give us 4 plus 4, which is going to give us 8. So root 8 is actually 2 roots 2 what? Units. So which is the distance between these 2 points, 3, 4 and 1, 2. That is for distance. Now, sometimes we may have to find the midpoint between P and Q. What is that midpoint? The midpoint between P and Q, let's just say, is the coordinates having maybe the coordinate of that midpoint. Let's just say x, xc and yc. Let's just say is a point on this line PQ. So the midpoint is going to give us, obviously, we're going to divide the point by 2. Because midpoint means average, dividing by 2. So in that case, we're going to sum x1 and x2. We're going to have x1 plus x2 all divided by 2, y1 plus y2 all divided by 2. So this is the formula, standard formula for the midpoint between 2 points. Obviously, if we take your P as 3, 4 and you take your Q as 1, 2, you can actually find the midpoint. Obviously, the midpoint is going to give us c, xc, and yc, which is actually equal to x1 plus x2 divided by 2. So we're going to have x1 is 3, we have 3, plus x is 1 over 2, x1 is y1 is 4, we have 4 plus y2 is what? 2 all divided by 2. So simplifying, we're going to have that this is equal to 4 over 2 and 6 over 2, which is actually going to give us 2, 3. 2, 3 is the midpoint of this line PQ, having 3, 4 and 1, 2. Because for the midpoint, we're going to add the x1 and x2, which is 4, and then divide by 2, which is 2, and also for y1 is 4, add it to y2, which is 6, 6 divided by 2, we have 3. This is actually the midpoint between 2 point P and Q. So the midpoint between two points is going to give us x1 plus x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. The next topic we're going to look at is the division of a line in a given ratio. Division of a line in a given ratio. Now, the same way, division of a line in a given ratio. We have division of a line segment. In this point, we're going to have in a given ratio. Not actually the midpoint now, but in a given ratio. So at this point, if you have this line, you have your x, you have your negative x, you have your negative y, you have your y. Now we have this point, this line P and Q. And we want to divide this line into two parts. Let's just say the ratio of m is to what? M is to n. So we're going to have that the ratio is what? We have ratio as what? M is to n. So the formula of this point, for us to get this point, now is going to give us n x2 plus n x1 over m plus n. That is for the xc. And for yc, we're going to have n y2 plus n y1 over what? N plus n. Obviously, you can see that if m is equal to n equal to 1, for instance, if m and n is equal to 1, obviously, your x subscript c is going to give us x2 plus x1 over what? Over 2, which is the midpoint. And also yc will give us what? Going to give us y2 plus what? Y1 over what? Over 2, which is actually the midpoint. Now, what if this m and n are of different ratio? So we're going to use the same formula. We're going to use this formula to actually find the point when this line is divided into the ratio m is to n. Sometimes we may divide the line internally, or we can divide the line externally. For internal division, you can see that obviously this m and n are positive. So, but for external division, that is dividing this line maybe outside the line. So that is external division. At that point, we're going to take either m is negative or n is negative. So we're going to solve different examples that will illustrate this division of line segments in ratios. So obviously, please take this formula. Let it be in your fingertips that m and n are not necessarily 1. M could be 3, n could be 5, depending on the ratio. Now, for instance, if you want to divide the line segments, let's just say P is having a P of x1 and y1, let's just say is having the point 3 and 4, and then Q is having the line, let's just say x2, y2 is having the point 5, 7. And we want to divide the line segment PQ. Let's divide this line segment in ratio, let's just say 2 is to 1. Now, if you want us to divide this line segment in the ratio 2 is to 1, these two now you're going to take your m, and n is going to take 1. And obviously, your x1 is 3, your x2 is 5, your y1 is 4, and your y2 is actually 7. So we're going to substitute into this formula. If you substitute into this formula, we're going to have that your xc, this xc is going to give us m is 3, sorry, m is 2, we have 2 times your x2 is actually your 5, you have times 5, then plus your n is 1, you have 1, times what? Your x1 is actually 3, we have 3, all over the addition of the ratios, which is 2 plus 1. So x of c going to give us 2 times 5 is 10 plus 1 times 3, which is actually 3 over what? Over 3. So we're going to have that x of c is going to give us 13 over 3. That is for the x of c, going to give us 13 over 3. Also, for y of c, for us to get y of c is going to give us m times y2 plus n times y1. So we take m as 2 again. We're going to have 2 into y2, which is 7, then plus your n is 1, and also what? Your y1 is 4 all over 2 plus 1. So simplifying, we're going to have 2 times 7 will give us 14 plus 1 times 4, which is going to give us 4 over 3. So this is going to give us 18 over 3. Therefore, we have x subscript c and that of y going to give us 13 over 3 and 18 over 3. So at this point, simplifying further, we're going to have 13 over 3 and 18 divided by 3 is going to give us 6. So this is actually the division of the line segment P and Q, having 3,4 and 5,7. That is the division of a line segment in a given ratio. So as a student, you should memorize this, where m and n, where m plus n, it is not equal to 0. For us to have a defined term, m plus n, it is not equal to 0. Now for external division, either we take m as negative or y or n as a negative. So we still do the same thing and compute. So that is it. Now the next one we're going to look at the gradient. Gradient. Let's look at the term gradient. Gradient. What is actually gradient? Gradient. Gradient. Gradient is actually called slope. So we're going to have the line. This is your x and this is your y. So the gradient slope. That is actually, let us say here is your P and also your Q. P is having x1 comma y1, and Q is also having what? X2 comma what? Y2. Now let's look at the gradient. Gradient is actually the distance increase in y over what? Increase in x. So we're going to have that gradient in terms of slope. You say m is the slope, which is going to give us increase in y over what? Increase in x. So increase in y over increase in x is going to give us the slope. So what is actually the increase in y? The increase in y is this line, which is distance y2 minus y1, and increase in x as is going to give us x2 minus x1. So what actually the increment? The increment is actually your y2 minus y1 over x2 minus x1, which is actually our slope. Do you know that this slope, we can actually have an angle? So from secant, we can see that this is opposite to what? Adjacent. So this is actually tan theta. So you can see that this implies that m is actually what? Tan theta. So sometimes, if theta is given, you can actually say that slope is going to give us tan what? Theta. But what if the slope is not given? What if the slope is not given, but the angle, what if the slope was not given? So we can use tan theta. But in the case whereby tan theta was not given, we can actually say theta is going to give us tan inverse of what? M. So tan inverse of slope is going to give us the angle between that line. So the next one we're going to look at angle between two straight lines. Angles between what? two straight lines. Angles between what? Two straight lines. For instance, if you have this line, let us say have this line, have this one. So we have, let us say here is A, and here is your B, here is your C, and here is your D. So we just say, let's form an angle on this. Let us say here is theta 1. Then here is also what? Let us say theta 2, for instance. And then we want to find angle between these two lines. Obviously, these are alternates, so they are the same. So you can see that from, and also this one is also what? Corresponding. So at this point, we can see that sum of exterior angle will give us sum of what? Interior angle. So in this point, we're going to have that theta going to give us theta 1